Okay, so this is worksheet number 3 from chapter 9. So we're looking at problems 2 and 5. The first thing I would do for number 2 is I'd want to start by factoring really everything. In this case, really all we need to worry about is factoring the denominator since the numerators are both prime. So to factor x squared minus 6x plus 9, I need two things that multiply to give me 9 and add to give me negative 6. So that would be negative 3 and negative 3. And then if I look at x squared minus 3x, well, that just has a greatest common factor of x. So I can factor that off. And now what I need to do is I need to look at the two denominators here. And I need the least common multiple from those denominators. So I'm going to really think about x minus 3 as times x minus 3 is x minus 3 squared. Because I see two distinct prime factors here. I see x's and I see x minus 3's. So my least common multiple will contain each of those. And then the power on my x should be the biggest power on all my x's here. Well, I have only just one thing that has it, or one x, and it's to the first, so that should be an x to the first. And then if I look at my x minus 3's, I have those in two locations. The biggest exponent on the x minus 3's is a 2. So that's my least common multiple. So I'm going to multiply both sides of this equation by x times x minus 3 squared. So distribute it to both. So when I do that, I have x times x minus 3 squared. Really, that's going to be over 1 times 9 over x minus 3 squared equals 3x over x times x minus 3 times x minus 3 squared over 1. And I'm going to reduce. So x minus 3 squared will cancel with x minus 3 squared. The x will cancel with the x, and one of these x minus 3's will cancel with one of those x minus 3's. So what I'm left with now is 9x equals 3x times x minus 3. And this is now no more fractions, and it should be relatively straightforward to handle. So I'm going to start by distributing that 3x. And then I'm going to have a quadratic equation here. So to solve it, I need to get it equal to 0. So I'll subtract 9x from both sides. And now to solve this, I'm going to do it by factoring. And since there's no constant term, the factoring is quite easy. All I need to do is take out a greatest common factor. The greatest common factor here is 3x. Oops. So when I take out a 3x from 3x squared, I'm left with x. And when I take out a 3x from 12x, I'm left with negative 4. And then I just apply my zero product property and set each of these equal to 0. So here I get x equals 0, and here I get x equals 4. However, I need to go back and check. So when I go back and check, I have to check at the very beginning. So let's say we're checking with x equals 0 first. And if I notice right here, if I plug 0 in for x, I'm going to get 0 in my denominator. So this one is extraneous. I'll discard that. And if I plug x equals 4 in, really, I would probably be looking here. It's a little bit easier to see. Because if any of these factors end up being 0, then the whole denominator ends up being 0. But this one works just fine. So x equals 4 I will keep. And that's that. For this one, for number 5, the same idea. So I'm going to look to try to factor the denominators. And lo and behold, everything is really prime, all the numerators and denominators. So there's nothing really to do there. So let's look at the least common multiple for my denominators. So my denominator here contains an x, so that's a prime factor. The denominator on the 2 is really a 1, so we don't care about it. And then x plus 3 is also prime, so that's a distinct factor. So my least common multiple will just be x times x plus 3. So that's what I'm going to multiply to both pieces. So I'm going to distribute that through to each piece. So I'm going to have x times x plus 3 over 1 times 5 over x minus x times x plus 3 over 1 times 2 over 1 equals x times x plus 3 over 1 times 2 over x plus 3. So now I can reduce. The x's here will cancel, and x plus 3's will cancel. So what I'm left with then is 5 times x plus 3 minus 2x times x plus 3 equals 2x. So now I'm just going to distribute these things through. So that's going to give me 5x plus 15. Now be careful here, this is a negative 2x, so I have to make sure I take my negative sign with me. Specifically right here, it's easy to forget that. And let's combine some like terms. So I have negative 2x squared minus x plus 15 is equal to 2x. So let's get this all equal to 0 since it's a quadratic. In general, I find it easier if the leading coefficient is positive, so I'm going to move everything onto the right side. So I'm going to add 2x squared over, add x over, and subtract 15 over. And what I'm left with is this quadratic equation. To solve this, I can either try factoring or I can use the quadratic formula. Since the leading coefficient is not 1, I know the factoring involved will be kind of lengthy. So rather than dealing with that, I'm just going to apply the quadratic formula. I think this one will factor, just looking at it briefly, and you're more than welcome to do it that way. It's not a big deal, but I'm just going to use the quadratic formula here. So 9 times 8 times negative 15. I'm sorry, 9 minus 8 times negative 15 gives me 129. And the square root of 129 is not a perfect square. So this is really as good as we can do. So the last thing I have to do is kind of check this. But this is easy to do. Obviously, whatever that number is, when I plug it in for x, isn't going to give me 0. And it's certainly not negative 3, so when I plug it in there, I wouldn't get 0. So this is just as good as I can do. And that's it. I hope that helps.